I'm now moving on to the next set of homework questions in chapter number 6. And for these problems, I need to continue evaluating the indefinite integrals. And some of these questions in this homework video guide, I'll be dealing with functions like e to the x. But in this case, I'll have e to the power of a number like e to the power of 3x and e to the power of 2x. Now, these definite integrals, they're not too hard to evaluate as long as you follow the general rule down here, which I'm highlighting in orange. So if you have a number here, like k, the antiderivative would be 1 over k times e to the power of kx plus c. So for the very first problem, e to the 3x, you should recognize that the value of k is going to be 3. So to evaluate that first part of the problem, e to the 3x, it's going to be 1 over 3. The pen's not working. Times e to the 3x plus, and then for this particular problem here, the k value is now 2, so that's going to be 1 over 2 e to the 2x plus c. And that's your final answer. Now, once again, you can always check your answer by taking the derivative of your final result. So if I take a look at this expression right here, what's the derivative of that? Well, the derivative of e to the 3x, well, that's e to the 3x times by 3. But you still have the coefficient of 1/3 at the front. And you'll notice that the 3's just cancel off here, and you're left with e to the 3x plus 1/2. And then the derivative of that guy is going to be e to the 2x times 2. And then the 2's will cancel off, giving you plus e to the 2x. And the derivative of c is just 0, so plus 0. And once again, if I take a look at this expression right here, which was my derivative, it does match up to the original problem. So you do know that your answer is correct. Okay, so let me just erase all this. And once again, let me just kind of get back to the final answer here. This was your final answer for that particular problem. Okay, let's move on to the next one here. Okay, so for this particular problem, I'm just going to rewrite this as the integral of e to the power of -1u. So the variable now is u, not x, plus e to the -1/3 u, and then times by du. Okay, so let's go ahead and use the rules here. So if I circle this, the k value here is -1. So it's going to be 1 divided by -1, e to the -1u. That takes care of that one, plus. Now the k value over here is going to be -1/3. So that's going to be 1 divided by -1/3, e to the -1/3 u, plus c. Alright, so that's how you would write it out roughly, and then after that you just want to clean this up. So 1 divided by -1, that's just going to be a -1, so negative e to the -u. And then I have a 1 divided by -1/3, and there's a positive sign there, so that's simply going to be -3 e to the -1/3 u plus c. Alright, so for that particular question, just find the value of k and just follow the formula that was given to you at the start of the problem, and then that should be a very quick problem in my opinion. Okay, let's move on to a new problem here. Question number 5. And for question number 5, this time I have a number 10 to the power of 3x. So I'll be using this new formula right here. So the a right here, that's kind of acting like the 10 here. And then the k is now going to be 3. So in order to follow the rule, it would be 1 over k to start. So my k value is 3, so this should be 1 over 3 times. Now a to the kx, well, a is 10, so 10 to the 3x divided by ln a, and ln a, now the a value is 10, so this will be ln 10. So if you follow the rule, that's how you would execute the first part of the problem, plus, and let me just erase all this. And then I have sine 2x, so I can just follow that over here now. This time the k value is going to be 2, so that's going to be -1 over 2 cos of 2x plus c. Alright, so let's just transfer that answer over. So -1/2 cos 2x plus c. And after that, we can just clean this up. So maybe I can write this as 10 to the power of 3x divided by 3 times ln 10, and then minus 1/2 cos 2x plus c. So the first few problems in this video homework guide, they're not too bad. You're just kind of asking yourself what is the right formula that I need to use so I can find the antiderivative. And for my next question, before I can use any formulas, I can do a little bit of algebra work at the start. So I can distribute the 4t into everything into the brackets. So if I do that, that's going to be 4t plus. Now if I multiply 4t and 4 to the power 2t, since the bases are the same, you just add the powers. So t plus 2t is going to be 3t. So this is 4 to the power of 3t. So plus 4 to the power of 3t, and then I have my integral signs there, and then I can just follow the rules to finish off the problem here. So for this particular problem, if I line this up with the rule here, I guess the k value here is going to be 1. So if I go ahead and find the antiderivative, it's going to be 1 over 1 because the k value is 1 times 4 to the t divided by ln 4 plus, and now my k value here is, this one's a little bit more obvious, the k value here is now going to be 3, so that's going to be 1 over 3 times 4 to the power of 3t divided by ln 4 plus c. And I guess for that one, I mean, you could definitely clean this up a little bit, but all I can really do is do 4t divided by ln 4 plus 4 to the power of 3t divided by 3 ln 4 and then plus c. And that should do it for that particular problem. All right, so the first few questions, definitely not too hard. For question number 7, we would definitely have to rewrite this. So this is the integral of 3x. And because you have a square root here, you can write this as 3x to the power of 1/2 times dx. And then after that, we can just distribute this. So this is going to be the integral of 3 to the power of x over 2 times dx. And actually, I'm just going to rewrite that one more time as the integral of 3 to the power of 1/2 x times dx. And one of the reasons I'm going to rewrite like that is because then it's pretty obvious to find out what the value of k is. K is 1/2. So now I can follow the formula now. So it's going to be 1 over k. So it's going to be 1 over 1/2 times 3 to the 1/2 x divided by ln 3 plus c. And after that, we can just clean this up. Remember, 1 divided by 1/2 is going to be 2. So remember, 1 divided by 1/2, that's the same thing as 1 times 2, which is just 2. Okay, so that's going to be 2 times, I'll put this in brackets here, 3 to the power of 1/2 x divided by ln 3 plus c, and that's your final answer there. Okay, let's go on to a few more. I have some trig questions now. Okay, so I'll do this the long way. I'll just distribute the integral sign. So this is the integral of cos 3x times dx plus the integral of sine of bracket. Now I'll write this as 1 over 2 times x and then dx. Oops, I'll put the dx in black there. Okay, so let's take a look at this very first integral right here. I guess I can match that up with this formula right here. And I know the k value is going to be, the k value here is now going to be 3. So if I follow this, it should be 1 over 3 times sine of 3x, and that should do it for that particular part. And then I have a plus sign, and let me just erase this now. Let's take a look at this expression now, and I can match that up with this expression right here. And the k value here, if you look at the k value here, the k value is going to be 1/2. So if I follow the formula, it's going to be negative 1 over k. So negative 1 over, the k is going to be 1/2 times cos of 1/2 x plus c. And after that, let's go ahead and simplify this. There's a plus and a minus sign. So this will be 1 over 3 sine 3x minus Okay, now we have 1 divided by 1/2, which is simply going to be 2 times cos of 1 over 2x plus c. Okay, so there you go. That's how you complete question number 8. There's about 2 more problems to go and then we're done, but most of these questions are the same kind of patterns. You know, you have to find the right formula and then you got it. For this next particular one, it doesn't match up nicely with one of the formulas. It's the integral of sine of 2x plus 1. What you can do is the antiderivative of sine of kx dx is going to be this negative 1 over k times cos kx. Now the problem is k is not a nice number here because I have this 2x plus 1, but what we can do is we can line up the sine with the cos right away. So I know this is going to be cos of bracket 2x plus 1. And then what I'm going to do next is, remember, when you take the derivative of cos, that's going to be negative sine bracket 2x plus 1, and then using the chain rule you would get 2, right? So ask yourself, how do I get rid of this 2? Well, in order to get rid of that 2, you need a 1/2 in front. All right, and then ask yourself, how do I get rid of this minus sign? If you want to get rid of that minus sign, you should also have a minus sign in front, like that. So it should be negative 1/2 cos 2x, and then just add your plus c. Okay, so that one you might want to think about a little bit more instead of just trying to follow the formula, because it doesn't follow the form. It's not written in a way where you can use the formula directly. But if this is your answer, just take its derivative. What's the derivative of cos? Well, the derivative of cos is going to be negative sine bracket 2x plus 1, and then using the chain rule, remember the chain rule of that is going to be just 2, and then you still have this negative 1/2 in front, right? And then the derivative of c is just plus 0. And then you'll notice that this negative 1/2 and this minus sign and that 2, it all cancels out. And what you're left with is just sine 2x plus 1, which is what the original problem is. So that question you might want to think about a little bit before you execute that one, because you can't really use the formula right away. Okay, so move on to question number 11 to finish off this video here. I do have a power of 2 here, so we do need to expand this particular problem before I can use one of the formulas here. So this e to the t plus e to the negative t times e to the t plus e to the negative t. And then I need a dt at the very end. And then after that, we can start foiling this out. So e to the t times e to the t is e to the 2t. And e to the t times that is going to be, well, let's just do this on the side here. It's going to be e to the t times e to the negative t, which is e to the power of t minus t, which is just e to the 0, and e to the 0 is just 1. Sorry, the pen's not working there, just 1. So I'll put a plus 1 there. And then you'll see that if I multiply the inside again, that's the same thing as the last calculation, so that's going to be plus 1. And then finally, I have e to the negative t times e to the negative t. So that's going to be plus e to the negative 2t. And then my integral signs, and then dt. And then just before I continue here, let's just go ahead and combine the middle terms. So this is e to the 2t plus 2 plus e to the negative 2t times dt. Okay, so now I'm in a pretty good situation where if this is my new expression here, I can definitely line it up with one of my formulas there, and I can get to the right answer here. So over here, my k value is 2. So if I want to find the antiderivative, it would be 1 over 2 e to the 2t plus, and then I have a constant. So constants are very easy. It's just, you just add a variable to it, so plus 2x. And then my k value here is negative 2, so that's going to be plus 1 over negative 2 e to the negative 2t plus c. And then after that, I guess you can just clean this up. 1 over 2 e to the 2t plus 2x. And then there's a plus and a minus, so negative 1 over 2 e to the negative 2t plus c. All right, so that concludes this video here. Most of the questions here is more about finding the right antiderivative formula and just maybe rewriting the question so that you can use the formula and finding the values of k so that you can just copy it right out. So most of these questions aren't too bad. And just try the questions a few more times if you're still not comfortable with the general ideas.